Well, hello everybody. Thank you for soldiering on past the snacks and well into the afternoon. I'm going to be talking a bit about web standards today, what they are, how they are made, and how we are moving them forward faster today than we have in the past. So my name is Bear Travis. You can find me on GitHub at BeTravis, which is where these slides will be posted after the talk, or on Twitter at Bear_Travis, where you can ping me with any questions you might have. So a bit about me. I work at the web engine team at Adobe, and besides having a penchant for blue beanies, we occasionally do work on web standards, both creating them and implementing them in engines like WebKit. So I've already said it a couple times already, so you may be wondering, what is a web standard, what qualifies and what doesn't. And so I found this definition that I like, called by Roger Johansson, who said web standards are technologies established by the W3C and other standards bodies that are used to create and interpret web-based content. These technologies are designed to future-proof documents published on the web and to make those documents accessible to as many people and devices as possible. And I like this definition of web standards because they kind of describe what web standards aspire to be. Like when you have standards, you can create documents that are future-proof. They will work today as well as they will 5 years from now. You're also making documents accessible to as many people accessing your content as possible. They may come at your content from a whole bunch of different angles, and standards help ensure that people will reliably see that content. So one of the things that's unique about the web is that the web is viewed by a lot of different people on different devices, from desktop to tablets to mobile, using all sorts of different browsers. And unlike many other development environments, when you're working on the web, you don't necessarily control how your content is going to be viewed. Your users could be using any of these browsers, any of these devices, in any area across the globe, accessing your content and expecting it to work. When you're developing for something like iOS or Android, you may have more reasonable expectations about what platform your end user is going to be using, because that's all your content's going to be accessible. But with the web, people can access it pretty much anywhere. What does that boil down to from an end user's perspective? What it means is that you should be able to write markup once and have a reasonable expectation for what it should display. So you should only have to describe this once to a browser and have it reasonably display the same content all across browsers and across devices. And so what this comes down to is basically, do browsers reliably implement a feature? Can you use one feature and expect all of the browsers to reliably show the same thing? And so I figured that it would be fun to kind of wake people up in the afternoon and take a poll. So media queries are one of the kind of relatively new features that enable you to customize the CSS for different devices and kind of different form factors that people may be using. So how many of you feel relatively comfortable using media queries in browsers today? Cool. I mean, it feels like they've been around for forever, right? So in terms of browser support, they're supported pretty much across the board. You just have to be aware that they were kind of implemented in IE 9+. So be careful of browsers less than that. How about gradients? Have any of you guys used gradients in your websites? Yep, I love them too. I kind of abuse them and make really ugly ones, but I'm sure that some of you have used them quite tastefully. So gradients are relatively new. Browser support's only relatively fair. They are implemented in IE 10+, and they are still prefixed in Safari and Chrome, and they're not yet in Opera Mobile. So border radius. This one does feel like it's been around for forever. How many of you guys have used border radius in your websites? Yeah, so pretty much everyone. I use it a ton too, and it turns out that, again, this is on IE 9+, and not yet on Opera Mobile. So you may be asking, what happens when you don't have standards? Things may be implemented in one browser, and we really just want to see if we can use it. When you don't have standards, you may wind up having to kind of write duplicate code to accomplish the same effect. So this is an example of adding an event listener just for a simple click event. And on the top, you kind of have what eventually became the standard add event listener. And below, you have kind of what was one of the early syntaxes on Internet Explorer. And so here you see that you're doing the same thing, but you're having to write 2 code paths for it. Not fun. And you may be asking, well, all of the kind of more modern browsers are using this. But if you look at kind of conservative estimates at places, i.e. Versions like below 9, it's still like 9% of the people who may be viewing your content. And this is like on the very, very low side of those estimates. So if you really want to target all of your users, you're going to have to write both of these code paths. OK. And then there's also kind of the case that happens when standards evolve after some functionality has already gotten out in the wild. So this happened with gradients, which we talked a bit about earlier. So there was no real standard for gradients, but people obviously wanted them. And so Microsoft started experimenting with early syntaxes in Internet Explorer versions as low as 6. But as you can tell, like, it's not really standardized. They're kind of still ideating, let's say. It's a little bit long and a little bit ugly. And it's not even valid CSS. So later on in version 8, they added kind of the MS prefix, and they made it kind of a valid CSS property. But no other browsers were really implementing it yet. And then Apple came along with its own proposal and decided to do an implementation in WebKit. So this made it into Safari and Chrome. And they kind of introduced this WebKit gradient syntax. But this never really made it to any of the standards bodies either. And so it wasn't until Mozilla came around and said, maybe we should work towards making a standard that all of the browsers can implement. And they came up with this syntax. And so this syntax is kind of currently supported by most of the major browser vendors, the current ones. And it's getting to become kind of a standard and something that you can use and reliably expect. But you can see that it's really only the cutting-edge browsers. So when you're talking about Internet Explorer 10+, you're still missing about 17% of the market, which means that in order to get this to reliably run, you may have to write all of those other syntaxes in one definition. So you may get like 10 lines of filter definitions just in order to get this to reliably run on as many browsers as possible. So when standards take too long to develop, you start getting things like quirks mode, basically when documents in the wild start relying on non-standard behavior, and you have to kind of keep that around in browsers, and nobody really likes that. And you start talking about legacy browsers, basically when you have to start talking about browsers that have behaviors that you don't want. So in terms of kind of getting all the players together and making them kind of conform to standards, standards bodies are really the people who do that work. And one of the major ones is the W3C, which is one of the main drivers for CSS. So the W3C has a more technical definition of what a standard is because they want to be able to define concretely what matches that definition and what doesn't. So they say the W3C publishes documents that define web technologies. These documents follow a process designed to promote consensus, fairness, public accountability, and quality. At the end of this process, the W3C publishes recommendations, which are considered web standards. So you can see that from the W3C's perspective, it's more about specifying or writing down standards than getting the actual behavior out in the browsers. Like what they want to do is they want to go through a formal process, writing this document up, coming up with a specification which goes on to become a recommendation, and that, they say, is a web standard. So the W3C process is very defined, as they mentioned before. There are 3 major stages. They have a working draft stage where specifications are basically they're basically subject to public review. And they can be kind of seriously revised during this stage. They then go on to become a submission, to become a candidate recommendation. And from there, the specification has to have 2 working implementations and a test suite that says whether or not browsers have effectively implemented that specification. From there, the candidate recommendation can go on to become a proposed recommendation and become accepted by the W3C as a recommendation, what they consider a web standard. So who exactly takes part in the W3C process? One of the nice things about the W3C process is that a lot of people are involved. So there are obviously the specification authors, the people writing these specifications. There are the specification implementers, the people who are actually implementing it in the browsers. And there is the community. Basically, anyone can comment on these specifications and help move them forward. And so as an example of how that has worked in the past, I want to talk about CSS Grid Layout. And what CSS Grid Layout is at its most fundamental is you can kind of think of it as as super tables. They're kind of a way of making tables that flexibly resize to fit their containers. And so what you can do is you can kind of define flexible rows and columns and then assign elements to those cells. But this is largely still taking elements and assigning them to cells within your grid. And when front-end developers and web designers start thinking about grids, they actually think about something more like this. So this is the golden grid system, but you can see similar ones in like Bootstrap or Zerb's Foundation, where what you have is you have kind of a set of measurements, and then you start aligning and sizing items to those measurements. What you're more interested in is kind of aligning to the grid lines rather than aligning to the cells created by those grid lines. This helps you kind of create responsive layouts where elements can resize and you can dynamically change the grid. And so some people from the community, as they were starting to review this CSS grid spec, said, hey, what you're writing is great, but in order for this to be really useful for me, I need to be able to align and size items to the grid lines, not just to the grid cells. And so CSS Grid Layout introduced line-based placement, where basically you could define the start and end points or define basically the widths of elements based on lines in the grid. And so, in terms of talking about specifications from a recommendation point of view, we can kind of revisit those three features that I talked about earlier and see where they are in the W3C specification process. So media queries. How many of you guys think that this meets the W3C definition of a web standard as a W3C recommendation? So we've got one person with their fingers crossed. So this did go on to become a recommendation, but it was only last summer that became a formal recommendation, even though it feels like media queries have been around for a much longer time. How about gradients? How many of you guys think that we've reached the recommendation standpoint for gradients? Okay, I'm seeing some kind of shakes of the head. And you would be right. So gradients are part of the CSS image values and replaced content specification. This is currently in that candidate recommendation stage where basically they're trying out implementations. They've more or less finalized what they think should work, but they want to make sure that it can actually be implemented in browsers. So this is a candidate recommendation. It went on to become that in last spring. And finally, border radius. So this has been around for a while. Lots of people are using it today. How many of you guys think that this meets the definition of a W3C recommendation? I see a couple hands. So this is part of a larger specification called CSS backgrounds and borders. And this is actually, surprisingly, still in the candidate recommendation stage. So this kind of shows how specifications and kind of the W3C recommendations may actually lag behind what people are actually using in browsers today and what many of us consider to be web standards. So then I guess the question becomes, which definition do we use for web standards? Do we use what is available in the web browsers, basically what we're comfortable using and having display reliably across whatever browser a user may be using? Or is it what kind of we have defined and have written specification for that's gone through this review process? And what that kind of influences is, where do we focus? If we want to move web standards forward as fast as possible, do we focus more on the implementation side or more on kind of writing and codifying the behavior? And so to give kind of an answer to this question, I'd like to go over a little bit of history, because hindsight is much easier than, say, future predictions, and talk about the past for CSS. So in 1990, Tim Berners-Lee develops the first web page and web browser. In 1994, the W3C is formed to help shape web standards. In 1995, we get the first public working draft of CSS1. This moves very quickly, and in 1996 becomes a recommendation. So you can see that there's basically a one-year turnaround from actually writing that to getting it as a W3C recommendation. 1997, we get the first public draft of CSS2. And in 1998, that goes on to become a recommendation. In 2000, the W3C starts thinking about CSS3. But then in 2002, they go back and kind of revisit some of the errata in CSS2 and start working on revision 1. And then that takes 10 years to become a recommendation. And so one of the questions may be, why does CSS2 revision 1 take 10 years of work, whereas CSS1 and CSS2 had really only taken 1 year to get a recommendation? And the reason was that CSS2 lacked a candidate recommendation stage before it went on to become a recommendation. So if you remember, that candidate recommendation stage is basically where a specification is put on hold until it's proven that 2 browsers are actually interested and can implement it. So what happened was a lot of browsers actually diverged from the recommendation for CSS2 that the W3C put out. And so some material was just slightly different, and so CSS 2.1 just was slightly altered in the behavior from CSS2. Some browsers expressed basically no interest in implementing parts of CSS2, and so those sections were removed in CSS 2.1. And then some material was added where browsers had basically gone off and innovated and created new behaviors and more or less standardized on them before the W3C had gone around to writing specifications for them. And so what this kind of shows is that standards synthesize implementation and specification. It's not really about one or the other, it's about both. You need to move both forward at the same time in order to effectively create web standards. If you have specifications that outpace implementation, you have things like CSS 2.1, where the final implementations may significantly diverge from what's written in the specification. If you have implementation that outpaces specification, you may wind up with things like filters, where basically the browsers have gone off and done kind of crazy things on their own, and in order to kind of corral them back in, you wind up with all these kind of legacy syntaxes that you have to fix up and support until you can reliably expect all of your users to be using standards-compliant browsers. And so the W3C is kind of a driving force behind this. It makes sure that specifications move forward, and also that kind of browser vendors are on board with implementing these standards. And then just the final thing is that standards are continuously evolving. As you can see from the example of CSS2, it wasn't like the specification was done and that was a standard. Really, the browsers had continued to implement new functionality, and what they implemented and what kind of CSS 2.1 came to agree on really became standards on the web. So where do these ideas for web standards come from? Obviously, there are some standards that basically just codify existing behaviors in web browsers, but sometimes the W3C is thinking more about what is coming down the line, like what is kind of what people are interested in using in the future. So they kind of have to do some brainstorming about where the web will be several years from now. And so an example of this is just text layout on the web. Like, there are a lot of different features being actively developed today, including some by Adobe, helping people do more complicated layouts on the web. And kind of as a history of text layout, just the simplest version is, the scroll. It's been around for a while. You lay out text from left to right, from top to bottom, and you need as much space as you have text. So the scroll basically becomes as long as you need it to fit all of your content. As your layout gets more complex, you may begin kind of playing with that layout so that you can wrap text through, say, multiple columns. You can wrap it in non-rectangular areas. So in this case, we are avoiding this fish-shaped area in the center and wrapping text around it. And then eventually, as our content gets really long, we may start actually dividing it into things like pages so that we don't have to have just one long scroll of content. So we can kind of divide it into pages and then bind it in something like a book. And we can see that these layouts are still very much in play today. So in something like a magazine layout, you may have kind of multiple articles running through custom areas, avoiding figures like these baubles here. And then, of course, this is all going to be bound into a magazine, which is paginated. And on the web, layout has started off very simply and is starting today to kind of explore some of these more complex layouts. So at its simplest and occasionally its most elegant, you still have the scrolling area of content. You have basically a web page. It lays out text from left to right, from top to bottom. The web page is as long as it needs to be in order to fit that content, and the user will just scroll down in order to view all of it. But like this site here, which is from tvsafety.org, people are starting to play with different ways of laying out the content. So here, we are laying out text within these circular bubbles here, and text is kind of wrapping to fit inside of them. And then we've also got these arrows on the left and right in order to navigate this. And using this, we're going to navigate through multiple pages of content rather than just scrolling through them. And so you can see that they've kind of divided their experience into pages. And then there are kind of some online magazine layouts that are becoming popular today, too. This is from The Great Discontent. And what you can see is basically they have one stream of content flowing down the center, above and below this diagram. And then what they've done is they've inserted a picture and a quote here into this stream of content. And so they basically have magazine content that is broken up being surrounded by figures and quotes. But these more complicated layouts are still a little bit tricky to accomplish on the web. And one of the largest reasons is because in order to express something on the web, as I mentioned earlier, you have to be able to describe it in a vocabulary that browsers will understand. You have to describe it in markup, HTML, CSS, JavaScript. And what happens when you have something like this? So you have content that wraps more tightly around this capital A here. And what happens when you have something like this, also running through multiple columns, where you don't have an easy translation to vocabulary that the browsers will understand, an easy translation to markup. So what do you write then? And I mean, you can get these effects by writing kind of complicated things. You can start dividing all of your text into spans and do complicated floats. But it's hard. It's not straightforward. And so regions and exclusions are two of the standards that Adobe is currently working on in order to make these layouts easier, in order to make it easier to basically customize how content flows through documents on the web. Regions basically customize the containers that you can flow text through. So rather than just flowing content through its current box, you can specify areas and then flow content through them. So here we have a stream of content, the gray content, that we're going to flow through boxes 1, 2, 3, and 4. And then we also have this white stream of content down here that we're going to flow through boxes A and B. And these boxes that we're flowing content through are called regions. And the content that we're flowing through them is called a flow. And so the markup for it looks like this. Basically, you specify that your content is going to go into the flow, basically something that regions can pull from later. And then you're going to mark all of your regions with this region class, and you will pull content from it using the flow from property. Exclusions are basically a complement to regions, and what they allow you to do is they allow you to customize the shapes that content flows inside and around. So here we can see that content is flowing inside of this circular shape, and also content outside of it is respecting the same circular contour. And the markup for this is, again, pretty simple. What we have is we have this circular shape. It's floating on the left. So you can see that this is that circle there. And what we do is we customize the shape outside, which is the shape that content outside of it is going to respect on the float. We specify that it's a circle centered at 50%, 50%, with a radius of 50%. And then we specify that the shape inside is going to respect the same shape as the shape outside is also going to be wrapped inside of that circular shape. So I have two quick demos of this functionality just so you can see it in action. Okay, I'm not going to try and full screen it. So this is basically just an example of flowing content through two columns, and again, wrapping it around that drop cap. And we can see that all of these columns are kind of sized to be about the size of the viewport, so people can basically scroll down the content and see this multiple column experience. And all of this content is, again, part of basically just one div that's marked as content and then flowed through these multiple regions. And then this is an example of just customizing the shape inside. So we can do kind of something a little bit eccentric, like flowing text through this tail shape on the mouse. And you can see that, if we say zoom in, then it's not something like an image. It's going to actually be the text. So it appears nice and crisp and clean. Okay, so Adobe is trying to kind of move these and get these into the hands of web developers as quickly as possible. And how do we accomplish this today? So of course, because we're working both in specifications and implementations, it's important to move both of them faster. So we'll talk about the specification piece first. And one of the simplest ways to move specifications forward faster is by reducing their complexity. So CSS1, just as a measure of complexity, started out with about 25,000 words. CSS2 had about 92,000. CSS 2.1 had about 140,000. And then CSS3, which is still very much in flux, so standards are kind of being added or removed from it. This was a count I did back a couple of months ago. It's currently at about 390,000 words. So you can see that it's getting much more complex, and trying to finalize something all in one go is going to take a lot longer. So what specifications and standards do these days is they basically move forward individually. They're broken up into modules, and then each of those modules can move forward with testing and specification and implementation all separately. So one specification may actually finalize in the level 3 spec and move on to level 4 before another spec may actually finalize its level 3. And so as an example of basically how much the W3C is doing this, especially with CSS, this is the list of current CSS work that the W3C is doing. And there are about 50 plus specs that have currently been broken apart and are currently moving forward individually there. So regions and exclusions are kind of examples of this new modular philosophy. They were actually proposed initially as a single spec, and then the W3C kind of said, there may be enough here to actually make it two. And so they were broken up into two separate specifications, and kind of ideas that have come along since have either reused functionality defined in regions and exclusions, or kind of been spun off into new specifications so that these two can remain as focused and lightweight as possible. So for example, when you're using regions, basically flowing content through custom areas, it may be nice to define templates. So you basically reuse that template as many times as you need in order to place all of your content into these templates. And this was an idea like, hey, it's really useful to define a template with regions, so you can basically flow your content and reuse the template as many times as you need in order to kind of make a nice paginated view. But rather than include this in the region spec, it was spun off into a different specification called the page template specification, conveniently enough, that can be moved forward independently. Another example of this is fragmentation, the idea that basically you want to be able to specify breaks across region in your content. And originally this had been part of the region specification because, well, it was important to be there. But it turns out that there are several other features that are currently being worked on that break content across multiple containers. And a lot of that behavior is being codified in something called the CSS fragmentation specification. And they also specify how content breaks across these multiple fragments. And so rather than kind of having a separate definition in the region specification, the breaking behavior was moved over into the CSS fragmentation spec. And then there was CSS masking, which folks have kind of started to codify how content can be clipped and masked in CSS. And one of the asks for this feature was being able to specify shapes that you can clip content with in CSS. So you need to be able to define shapes to clip content using CSS markup. And because CSS exclusions and shapes already has a syntax for that, the CSS masking spec just reuses that syntax. But it turns out that there's kind of a limit to how modular or lightweight we can make any individual module. And one of the reasons for this is that each module is really part of a larger tool set. In order for these modules to be successful as features, you really need to be able to use them effectively with any other feature in the tool set that you may want to. So as an example of this, CSS regions and exclusions were proposed as a single specification because they're supposed to play well together. So you should be able to define custom regions in your content, and you should be able to customize the shapes of those regions and how content flows through them. So in this example, you can see that you kind of have CSS regions and exclusions as one stream of text running through two regions with these triangle shapes applied to them. And so, in the markup, this is pretty simple. You have regions, they have a shape inside, which customizes the shape that the content flows inside. And then you have content, which is going to be flowed through them. But then the question then comes up, well, what happens if both the regions and the content have a shape inside on them? So in this example, what happens if you have these triangle shapes on the two regions on the left and right, and then the content itself that you're flowing through it has, say, a circular shape? And so what we've decided to do for right now is basically use the intersection of those two shapes. But it's kind of an example of how you need to think about how specifications interact when you're writing them and implementing them. Another example of this is regions in multi-column. So you can use regions basically to break up multi-column elements. So in here you could say have multiple pages that you use regions for, and inside each of those pages you have a multi-column layout. So it's something like we saw in the Alice demo, where we want content to flow through these columns first, and then move on to the next page and flow through the columns there. But if we're not careful in specifying kind of which of these containers has priority, content might flow through the columns first and then be broken up into separate pages rather than flowing through the regions first and breaking up into columns. And so you might wind up with basically these super long columns that are broken up across pages. And this obviously isn't what you want either. So you need to make sure that your specifications work well together. And so the flip side of writing faster specifications is getting faster implementations, basically getting this functionality available to people faster. And one of the things we're seeing today is that web browsers are releasing just much faster than they have in the past. So all of the major browsers are releasing test builds before their final release versions go out. So if you're interested in trying out features, I would encourage you to download and try out their test builds. Many browsers are also releasing something called an experimental channel, something like Chrome Canary or Aurora for Firefox, which basically installs alongside your standard release browser, automatically updates to the latest build. And so basically you have a browser where you can test out experimental features without having to download a new version all the time. And it also kind of doesn't overwrite your current browser. So you can go back to your regular release browser when you want your everyday browsing experience. Other part of this is that release builds are also coming out more frequently than in the past. So your actual, like the browser that you use every day is coming out more frequently than in the past. Because in the past we've had release cycles, say, every year, every 2 years. And obviously, the web is moving forward a bit faster than that. So we're seeing release cycles in as short as 6 weeks with some of the major browsers today. So native implementations have a couple benefits. They prove that a feature can be done. They prove that it can be done in a performant manner. And they prove that it can be done just like any other web feature. After all, it is a web feature when it's made it into browsers. The downsides of native implementations, though, are that you're tied to a specific browser when you implement it. Your code isn't going to go out except for on the release schedule for that browser. And because it's a shipping product, it may have really kind of high standards for review and implementation. So getting code out in a browser release can take a bit of time, and it's only going to be in only one browser, so. So what we really want to do is we want to get functionality in the hands of people faster. Because what it boils down to is letting people play with these features, see if they do what they need them to, and then getting feedback on the specification. So one of the ways we're doing this today is using polyfills. So how many of you guys have used a polyfill in web development? How many of you have heard polyfills as a big buzzword? OK, so I'll go over them really fast. The basic idea is that you have something like a JavaScript library. It sits on top of your HTML. And when you have a new feature that's implemented in some browsers, but not all, especially something like legacy browsers, the polyfill will go through your document and transform it into something that older browsers can understand. The idea being here that you can use newer features that are supported on some of the newer browsers, and then you'll have a fallback for older browsers. But what we're seeing today is that people are starting to play around with polyfills before reliable implementations have actually been released on any browser. And so what you're seeing is that people are starting to release polyfills so that you can play around with basically the newest cutting edge features that are currently being worked on in the W3C. So the advantages of polyfills, of course, are that they work now. They can work across browsers if people take the time to do that. They can be replaced by native functionality because, again, this functionality is supposed to be supported in the future. We're only kind of backfilling it with some JavaScript and some additional markup for now. And they also kind of let you try out new features. So an example of this is the CodePen Rodeo. And what happened was CodePen was doing a series of basically kind of user experiments. Basically, it would give a topic for a week, let people try to play around with that challenge, and kind of see what people created and what they came up with. And because Adobe had released a polyfill for regions, we were actually able to do a regions challenge 1 week. And so the great thing about having a polyfill was basically people could use it with their browser of choice. They could go through and kind of start playing around with it without kind of downloading a fancy test browser or anything. And they could start just kind of seeing what they could build. And so it was really great to see what people tried to create with regions and what they were kind of interested in doing. And this is, again, when we don't have a reliable implementation available by default in any browser. So of course, there are a couple downsides to polyfills. They are a workaround of course, because the feature isn't implemented yet. Polyfills start getting written relatively early in the specification process a lot of the time. And so you can see the specification change, and sometimes there are significant changes in the specification. And that means that all of the code that you took so long to get working with the polyfill for the native implementation to work later may wind up being out of date. And then the other final reason is, or downside of polyfills, is that they can be a bit non-performant. They're doing a lot of work on the client side sometimes in order to get markup that simulates this effect that you're going for on older browsers. And so they can be a bit slow. So if you are interested, I have up here a bunch of kind of polyfills that I think are really cool that you can play around. Up on the Modernizer site, which I've linked at the bottom, there are a bunch more basically for any specification that's out there on the web that you might be interested in using. There's probably a polyfill for it. And so I would encourage you to go and check them out. So the cool thing about standards today is that they aren't standing still. The implementation and specification pieces are moving forward all the time. We're getting new polyfills out there. And so kind of what you might actually be able to use can change on a daily basis as people release new functionality with browsers. This is an older version of the talk. So standards are basically, they're tools. And the goal for them is basically for you to be able to write, you want to get something on the web, and you should be able to describe that in markup and have it run on any browser that works with web content. So that's really the goal for standards. And so I'd encourage you to help get them where they need to go. So you can always grab a test version of your favorite browser. You can test out a new feature, including using polyfills if it's not currently implemented in that browser. Writing up bugs for implementation is a great way of finding out what people are interested in working. And then you can always give feedback on specs. So all of the standards bodies on the web are really open to public review. And so if you see kind of a standard that you're interested in that kind of maybe isn't going exactly where you think it should be going, or you would like to see it be slightly different, let the spec authors know. And so that concludes the talk. Feel free to ask me any questions, but if you need to run because it's getting late, I won't have my feelings hurt. Thank you.